Hello students. So we are doing limits and derivatives. We have seen derivative of sin x, cos x, tan x, cot x. Okay, by first principle method. We'll do today derivative of sec of x. Okay. So f of x plus h is x plus h. F dash of x is limit as h tends to 0. Sec of x plus h minus sec of x upon h. Okay. Sec of x plus h is 1 upon cos of x plus h minus 1 upon cos of x upon h. So cross multiplying you will get cos of x minus cos of x plus h upon h into cos of x into cos of x plus h. Okay. This you can expand, that is using cos a plus b formula. So you will get here cos a cos b minus sin a sin b. Okay. So we can take this as taking here cos of x common, we'll get this is minus, and when I remove this bracket you will get here plus 1 minus cos h. Okay. So I can split this denominator. Okay. So we'll get here this as limit h tends to 0. 1 minus cos of x upon x is 0. Correct? So this whole term is 0. Then for this sin of h upon h is 1. So we'll get here only sin of x upon cos of x, which is tan of x, and when h is 0, this becomes cos of x. That is tan of x into 1 upon cos of x, which is sec of x. So your derivative is tan of x into sec of x. Okay. Next question. F of x is equal to cosec of x. F of x plus h is cosec x plus h. Okay. So f dash of x is limit as h tends to 0. Cosec of x plus h minus cosec of x upon h. Okay. Cosec of x plus h is 1 upon sin x plus h. Sin of x h. Okay. Cross multiplying of x plus h into sin of x. Okay. So we'll get your limit as h tends to 0. Here you can expand this sin of a plus b. Sin a cos b, I'll write it. Sin x cos h plus cos x sin h. Okay, so taking this minus sign inside, you will get here minus. Okay. Again, sign of x you can take common. So sin of x is common. 1 minus cos of h, and I'll write this denominator minus cos of x into sin h upon h into sin x plus h into sin x. Okay, so this thing becomes 0, so whole thing becomes 0 as h tends to 0. Here this becomes 1, sin of h upon h. So we'll get here minus cos of x upon sin of x is cot of x, and as h tends to 0 this becomes sin of x. So 1 upon sin of x is cosec of x. Let's find out derivative of a constant function f of x equal to a. So f of x plus h is also a, right? So f dash of x is limit as h tends to 0 a minus a upon h, which is 0 by h. Okay, which is equal to 0, where h is not equal to 0. So derivative of a constant function is always 0. Okay, then we have derivative of 1 by x. 1 upon x plus h. F dash of x is limit as h tends to 0, 1 upon x plus h minus 1 upon x upon h. Minus h x plus h into h. So this is minus h upon h gets cancelled. When h is 0, then you will get 1 upon x square. Okay. Let's learn algebra of derivative of functions. Okay. So it's simple. When it is addition, you have to take derivative of both with plus or minus. That is d by dx of, suppose you are given f of x plus g of x. Then it becomes d by dx of f of x plus d by dx of g of x. Okay, plus or minus. Then multiplication is also same, and for not multiplication is same, you have a product rule and a division rule. Okay, so the division rule is called quotient rule. So for a product rule, we take u as f of x and v as g of x. Okay, now when you want to find derivative of this, that is dash, derivative is also denoted by dash, right? So we have to do u dash v plus v dash u, that is derivative of u into v plus derivative of v into u. Okay, second is our quotient rule, u by v. So this is division. So here you have to do u dash v minus v dash u upon v square. Okay, these two rules you have to keep in mind. So let's solve some examples based on this rule. And derivative to find a polynomial, derivative of a polynomial function. So d by dx of x raised to n is given by n x raised to n minus 1. That is, if you are given d by dx of x cube, okay, then your n is 3, x raised to 3 minus 1. So 3x square. This is the derivative. Okay. Let's find out derivative of fx plus 1 upon x by product rule. Quotient rule, sorry. Okay. So I'll write here what is my u. U is x plus 1 and v is x. Okay. Derivative of u is derivative of x is 1. Right. Because raised to 1 is there. So 1 minus 1 becomes 0. So 1. Derivative of 1, that is constant function, is 0. What about this? This is 1. So using quotient rule, u dash v minus v dash u upon v square. U dash is 1, v is x minus v dash is 1, u is x plus 1 upon v square. Okay. So minus 1 upon x square is the answer. Let's solve this. So sine square x is given. So something square is given, right? So we have to use that x is to n formula, that is d by dx of x square is 2x, correct? So like this will be 2 sine x, but we have another function here, that is sine of x. So derivative of sine of x, by using first principle we got cos of x, so that you have to multiply. This is the derivative of sine square x. Okay. Another way to do this is f of x. You have to write sine square x as sine of x into sine of x. So now this becomes u, this is v. Okay. So u dash cos of x into v plus v dash into u. So this is 2 times sine of x into cos of x, which is nothing but sine 2x. Okay. Let's find out derivative of cot of x without using first principle. So cot of x can be written as cos of x upon sine of x, correct? So derivative, this is u, this is v. U dash is derivative of cos is minus sine and derivative of sine is cos of x, correct? So d by dx of cot of x is u dash v minus v dash u, v is sine of x, u upon v square. Okay, so here we will get minus sine square x minus cos square x upon sine square x. Okay, so minus sine square x minus cos square, minus I can take outside, so this will be sine square x plus cos square x upon sine square x. Sine square x plus cos square x is 1 identity, right? So minus 1 upon sine square x is minus cos x square x. This is the derivative. Let's find out derivative of this. Okay. Root of x means x raised to half. So here you can use that x raised to n formula. So f dash of x becomes n x raised to n minus 1 you have to do. N is half, x raised to half minus 1. So x raised to minus half, which is nothing but 1 upon 2 root x. Okay. So the derivative of root x is 1 upon 2 root x. F of x is, or y we can take, x cubed plus sin x plus e raised to x plus 7 raised to x. Okay. Now here you have to make use of derivatives which we have found by using first principle. Okay, that least you have to keep with yourself. Then you can solve this directly. So dy by dx, derivative of this d by dx of x cube plus this I am writing, but later on I'll directly write the derivatives. Okay, this is for your understanding. So derivative of x cube is what? 3x raised to 3 minus 1, that is 2. Derivative of sine of x is cos of x. Derivative of e raised to x is e raised to x. And derivative of 7 raised to x is log of 7 a raised to x, or 7 raised to x log 7. Okay. Okay. Now this is given in the denominator. So to derivate it, to write that in the numerator, how you write this? So power becomes negative. Okay. d by dx of 3x is to minus plus d by dx of root x. Okay. So this is minus 2 x is to minus 2 minus 1, which is minus 3. Here 3 is a constant, so you can take out 3. Then derivating x is to minus 3 is minus 3 into x is to minus 3 minus 1, which is minus 4, plus d by dx of root of x is 1 upon 2 root of x. Correct? So x is to minus 3 is x cube minus 3 3s are 9, 4. Okay.